Next is about external groove rough. So for this groove rough, we need a new cutter. So this one, the groove cutter, this is the cutter name. So we'll select this grooving insert and choose the tool holder, the first tool holder, and the tooltip orientation is on the right hand side, and the tip width is 4 mm, the tip radius is 0.32, and the insert width is 4.98. Okay, so follow this setting, the parameters. So I get the process turning rough, and this one I will modify the start point to this point, modify the end point to here. The start extension and the end extension will set it 0. Make sure the cutter is this. Then access to the tool trajectory. So I will use the outer diameter, and this one turn will change to plunge, and the angle will be 270. Calculate for the cut width will be 2.5 for the cut width, and I will on this center out cut, and the stop will be finished stop will be 0.2. The clearance will be 146. 146. So the rough style will use the full, and this one 136. The holder angle will be 90. So save and calculate. Double click to edit this process. So I will on this X positive direction. So calculate the process. So this is the result. As we can see here, the first plunge is in the middle of the what I call it, the groove. So this is where the insert is positioned, and the motions are drawn through its front corner radius center. On both sides there are a couple of the narrow space plunge, so which are derived from the fact that the insert corner radius is smaller than the groove bottom radius. So the system calculates these additional plunges in order to properly respect the required offset from the groove shapes. Next one, I will get the external groove finishing. So the cutter will use the same one, but this time draft will change to contour. So this contour, the start extension will change to 2.15. The end extension will be 1 mm. So we use the same cutter. So I will access to this contour dialog. So of the square corners, use the OD and 146. This one 0 and advance. Then the holder will be 90 degree, holder angle 90 degree, and entry or exit will be 3 mm for the entry radius, and the off part distance will be 1. So now I will on this no drag. So save and calculate. The motion starts with a tangent approach on the start side and continue downwards until the cutter clear of the right side fillet. Then lift up to repeat the same from the end side until the cutter merge with the start side cut. So this is the result of the no drag. The cutter means the cutter is not cutting backwards. So this is the result.